In 2013, 3 scientists were tasked with an impossible challenge: to categorize outer space's most interesting phenomena, the black hole. This is their story.
What are we doing about this black hole?
I wish there was something that we could take to help us visualize it.
I have an idea. Hello.
Oh, that must be him.
Cool, right?
Let's go get it.
Let's go.
Grab the door.
Yeah.
Fantastic.
Word.
Dank.
Hey man, this should be enough for you.
Thanks, Kaito.
Yeah. Have fun, guys. You'll see a lot of stuff.
What a cool guy.
A few moments later.
This is a black hole.
Three hours later.
Now, we begin our search for the missing scientists. How disgraceful. Onwards. Here is scientist Erick, who seems to have discovered a little friend of his own. What a Finally, the one scientist who seems to have reacted the worst. Now that we've recovered from our little trip, we've discovered a few things about black holes.
We've discovered that black holes are places where ordinary gravity overcomes all other forces in the universe.
A black hole is a region where gravity prevents anything from escaping. The theory of relativity, as stated by Albert Einstein, predicts that a sufficiently compact mass will deform space-time to form a black hole. Around a black hole is a mathematically defined surface called an event horizon that marks the point of no return.
Black holes of stellar mass are expected to form when very massive stars collapse at the end of their life cycle. After a black hole has formed, it can continue to grow by absorbing mass from its surroundings.
The first modern solution of general relativity that would characterize a black hole was founded by Karl Schwarzschild in 1916. So here is basically what we know so far.
General relativity provides a unified description of gravity as a geometric property of space and time. In particular, the curvature of spacetime is directly related to the energy and momentum of whatever matter and radiation are present. This relation is specified by the Einstein field equations, a system of partial differential equations. On the left-hand side is the Einstein tensor, which describes space-time curvature. On the right-hand side, T sub mu v is the energy momentum tensor. Physicists use these equations to describe black holes.
The shape of a black hole is a circle. It is round and it is very black. In fact, it is so black because no light can escape the black hole. If any particle or matter comes within contact of the event horizon, which is the outside of the black hole, it'll be sucked in and completely destroyed. Black holes are extremely interesting when light comes into play. Because black holes don't allow light to escape, photographs of black holes become very interesting. The above drawing is a galaxy passing through a black hole. As you can see, when the galaxy moves downward, the light becomes distorted and moves around the black hole. And the light always revolves around the event horizon. Here is a black hole with light distortion.
Scientist Sam, where have black holes been seen in our own society?
Black holes have been seen in a lot of popular culture today, ranging from movies such as Disney's Little Mermaid and The Help to the epic movie 300.
What?
This is madness! This is Sparta!
Moving right along.
Time travel through black holes is theorized by this guy, Machine Cocoon.
Let's take a look at what he has to say.
If you have an infinite cylinder and the cylinder rotates and you dance around the cylinder like dancing around the maypole, you can also come back before you left and meet your parents before you're born. Another way is to have a wormhole. Take a sheet of paper, draw 2 dots on it, fold the sheet of paper until the 2 dots meet, and that's a wormhole. Now there's a catch. Using Einstein's equations, you can show that the energy necessary to bend space and time into a pretzel is comparable to an exploding star, a black hole. Energy far beyond anything we can harness on the planet Earth.
So after all our research, we still have no idea what black holes are. So we took a little journey, and we're gonna go inside this mother.
It's time to go to other sources.
It's locked.
What is this? This is a cat!
So what do you think about black holes?
I think black holes are, this area in space that has a very high suction force that, once you get sucked in there, there's a place where, once you get there, it's a place of no return.
Yeah.
I think it's a matter of how.
In the middle of a black hole, there's a lot of pressure. And I remember watching a video in 7th grade, and the guy described it as if a human were to be there, they would get spaghettified.
Wait, have you ever seen a picture of a black hole or seen a black hole or?
Yeah, I probably have seen a picture.
Okay.
Have you been near a black hole before?
No.
Okay.
What happened if you put your finger in?
Black holes are those horrible tears in the universe into which all spinning matter gets sucked into and then turned inside out and spit out the other end.
Yum.
I don't really know much about them, but I know how you could see them. You can hit me up later if you want.
What I do know is that it's almost like a vortex that sucks you in.
Blah blah blah. Blah 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 blah.
Black holes are where matter in the universe has condensed to a point of almost kind of infinite density. One analogy I remember hearing was that if you took the mass of the Earth and you compacted it to the size of a basketball, maybe, that would be about the density of a black hole. And they're thought to be at the center of a lot of galaxies, which would create enough gravity to keep things moving around them.
So how does it feel to be awesome?
We both know why we're here. I see it in your eyes.
I know they're big. And they're black.